Alright, welcome back to what I can only hope are good choices. Mic check 1 2 1 2. We did go into the red a bit, but I don't know. I think too loud is probably better than too quiet. Too loud, you can turn it down. Too quiet, there's a max. So I'm going to keep it as it is. Last video, which was 2 days ago. Sorry, my production has been not quite what it used to be, but moving right along. So last video we made a part 1 on 1037. So made it all the way to the guided exercises. Now this is regular expressions, so these guided exercises and explorational exercises might be kind of long lived. So yeah, let's do that. Let's knock out this lesson 1 and put an end to and then move on to lesson 2 in the next video. So these are the guided exercises. So what regular expression would match any email address, like for example info at example.org. So let's think about this. So and then I'll just do it in Notepad++. So how many? So we learned about a number of things in regular expressions. We learned about some really important concepts. We learned about the concept of an atom. An atom is the individual unit in a regular expression. We also learned about the concept of a search string. The search string is the thing you are applying the irregular expression to. And then finally we learned probably the most important concept, and that is that a regular expression is not the same as a search string, and that the two often get conflated. So let's think about what this is here. Is this a regular expression or is it something else? 3 2 1. Okay, so the answer is this is something else. This is an example of a search string. So our job is to write a regular expression that goes through this string of characters and then provides a match or a non-match. Okay, so we're going to need atoms in a regular expression. So let's start with the first atom. So the first atom, let's have it be any character, and then let's have it be 0 or more times. And then of course we're going to need to match this at symbol. So we'll have that next. Then we can also have another string of characters, 0 or more times. So now we have 1 2 3 4 5 atoms. The first atom is the symbol here to match any character. The second atom here is to match the prior character 0 or more times. And then the third atom is this at symbol. So we're matching. We get an at symbol. Okay. So now we have a match. So the fourth atom is another series of characters. The fifth atom, 0 or more times. Not a series of characters. So it's an individual match. So the fourth atom is any character, and then the next atom is any character 0 or more times. So there we go. Now we know that the syntax of an email address is a set of strings on the left, a set of strings on the right, divided by a at symbol, and then a dot, and then 3 characters at the end. So now we need to match on the dot, so we can escape it into a literal character using the backslash. So I would argue that this is one atom here, and then we need a final atom to match any number of characters at the end. So I think this is going to be my answer. There can be more sophisticated answers than this. One thing that might be more sophisticated than this is if we have an email address that looks like this. Is this a valid email address? No, because you do need to have some characters on the on both sides. So another example, this isn't a valid email address either, and this expression will say that this is valid. This also is not a valid email address, and neither is this. So there's a lot of examples. Here's another one where we will get matches on things that actually aren't email addresses. So a better thing would be to match. We want to match any character, and then we want to match it three times. So I guess what we could do is we could say I think like this, because then this matches. This says there has to be 3 characters at the end, and that's the case for a email address. Now here there truly can be any number, but there do need to be 1. So I think we can use the question mark, because that means 1 or more instances, or the plus. I forget. Let's look back in the reading and see. Now these are bounds here. Oh, I see. So this was the wrong syntax. We got to do it like this. Okay, and then it's not the question mark quantifier will occur if the corresponding atom appears once, or if it doesn't appear at all. So we don't want that one. We want to for 1 or more. So that's the plus sign. So the plus sign quantifier will select pieces containing 1 or more atom matches in the sequence. Okay, so now this, I think, is my final answer. We see the difference here is we have 1 atom here, which is to match any character. Now we have another atom here that's different than what I had before. The difference is this matches the prior atom, which is any character, but it has to occur 1 or more times. Then we have a literal character here. As far as I know, if it's not a literal character, we will need to backslash it. So I'm kind of not sure about this one right now, but I believe it is literal. So we'll move on to the next atom, which is just like here before. Any character is fine, and then the next one, that prior atom, which is any character, needs to be matched 1 or more times. Then the next thing we're matching on is the actual literal period, which we get with this backslash for this 1 atom here. It's a 2-character atom. Then now here's where there's an error here. We don't need this asterisk anymore. So we're going to have a 1, 2, 3, 4. We're going to have a 4-character atom here. So the first character in the atom is a dot, and that says that this atom can match with any character. The next any character in the search string. The next character, and I'll do a quick mic check. I'm paranoid about this. The next character in the atom is a special character. It's a open bracket, and that specifies that there's going to be a bound. The 4th character is the number of times that the atom must appear exactly, and then the 5th character is the closed brace, curly brace, which specifies that it's finished with this atom. So we've got a 5-character atom here that says that any characters can show up, and they can show up. And they have to show up 3 times. So now what happens when we have this? So we're getting better. We're getting better. We're going to say hello at world.com. So this will be good. It's getting better. We won't match on anything like this. But where will we have a false result now? Let's think about it. So hello world.com. That one's going to match. But what if we had it like this or like this? Would we get a match? Well, the answer is yes, we would get a match because there's any character. What if we had dot 123? Is that valid? I don't know if that's valid. From what I understood, you needed some sort of three. You needed characters, not digits. So let's make this an even better regular expression. So, and then we'll use this alpha here, and then we know that. So we're going to make this quite a more complicated atom. We're starting to get to the point where it's really not Pythonic anymore, but it's going to be a much better regular expression. So now we've got a multi-character atom, probably over 10 characters, and we've got this special bracket expression that says we're only matching on. So if we have an address like this, we're not going to match on it. If we have an address like this, we're not going to match on it. So we're throwing away some false positives by making this more specific, and then we're keeping the bounds on it where it has to match 3 times. So I think this is going to be my final answer. Let's see what the answer is in the training materials. All right, so now remember, so this is the big distinction between the answer I gave and the correct answer. We're talking about extended regular expressions. So that's a big difference into whether or not the answer I gave is correct or not. Are the characters and syntax that I used in my answer part of basic regular expressions or extended regular expressions? That's important to whether or not the answer is correct. All right, so then let's look at this \s. All right, and I don't see that was explained anywhere in the characters. So I'm guessing that means that it's like this alpha here. Now let's take a look at alpha. Okay, so now the thing is with it doesn't say if these bracket expressions are a part of basic or extended regular expressions. So if they're not a part of extended and they're only a part of basic, then unfortunately my answer is incorrect. But I don't see that as part of the training. I will say this is kind of the first lesson I've had where I was like pretty disappointed. If you watch my last video, you'll know there's a section where like the last half an hour I'm basically just going over a really bad typo in it. So this is the first lesson where I'm actually like pretty disappointed because there's just so many conflated concepts, a basic and an extended regular expression. There's characters introduced where it's not clear whether they're part of basic or extended. There's it's just a complicated topic too. So it's like, you have to memorize syntax from basically multiple different forms of regular expressions, extended and regular. They don't give you clear examples. They don't even use the correct vocab pertaining to the concepts. They'll conflate a regular expression with a string of characters that you're searching. That is not the same as the expression you're using to search. So here's their answer. We can see it's pretty much similar. It's just this \s. Then they've got the plus symbol. Then they've got the at without being escaped. Then \s, which is kind of the same as I'm using. Yeah, so I'm going to say that my answer is correct. And not only that, I'm going to say that my answer is better. So let me try doing the I'll try doing both answers in my lab, and we'll see if we can pull out any IP addresses, or sorry, any email addresses. Alright, so nothing yet. What if I run it here? Okay, still nothing, so I'll try it with my answer here. Okay, so I think we do have oh, I used the wrong syntax. Is that a part of the Yeah, because yeah, so we need to specify that this whole thing is a single atom, which it is. Now here's the interesting part. Where do I close the parentheses or the square brackets? Because the whole atom includes the quantifier. So let's try it so that the whole atom includes the quantifier as it would be intuitively written. And there we go. So I think that is the right way to do it. So I like my answer better. It looks like it is an extended regular expression because it's running with the egrep with no problems. So that's a good answer. Let's run this again. Let's find a list of fake email addresses. Oh, let's ask the AI. I love the AI. It'd be perfect for something like this. Generate a list of 10 fake email addresses that I can use to practice writing extended regular expressions.
Before we proceed with creating a list of fake,
I've got the I gotta disable my prompts. Yeah.
Sure, here are 10 fake email addresses that you can use to practice writing extended regular expressions. Example answer 1 at fake domain 123. Contest.
Oh, and you know what's going on here? It's not that it's searching through, and I can go back to my home drive. It's that I didn't specify a place to search, so it's searching my standard input, the characters from my keyboard. That's what's going on there. It's important to know that. So that's good. That's where I want it to search. So we're gonna go like that. It's gonna just hang because it's searching for, it's searching standard input, so keystrokes, and we'll enter in all these email addresses. And let's see if we get any matches. Okay, so there we go. We do have matches here. All the things highlighted in red. So yeah, it looks good to me. Now we can see we do have some syntax. Now this, I remember this actually is valid syntax. So our expression is going to be a bit too restrictive. Let's try it with this other expression. Okay, so now you can see, yeah, mine's a bit too restrictive, And then not only that, it didn't work the way it was intended because it matched this other dot here, which apparently is a alpha character, and there's more. Yeah, I think it's yeah, I'm not sure what's happening with that because it should only be matching 3 characters after the dot, and it looks like it's matching 5 characters after the dot. So, it's an absolute failure of a regular expression. So, unfortunately, yep, that is the case. And their answer was the right answer. All right, so on to the next question. What regular expression would only match an IPv4 address in standard dot quad information like that? So let's think about it. Okay, so we do want digits to be matched. So let's use that special syntax digit. Okay, and then we're going to need a quantifier on it. So we can use the bounds here, which is an atom quantifier. So our atom is going to be any digit, and then it needs to appear at least 1 time, and then at most 3 times. All right, so that can be the end of our atom. So this is a single atom. There we go, and then we need a literal dot to appear, and then we need this whole expression here to appear 4 times, and each time separated by a dot. So one thing we could do is treat this whole thing as its own atom, and we can do that by putting it in brackets like that. Then we can add another quantifier, so it must appear at least 3 times. And we do 3 because the final appearance of it doesn't have to include this dot here. So we'll end this. This is 1 atom, and now we'll create a second atom like this that does not contain that dot. So here we have a 2 atom regular expression that will match IP addresses. So let's test it out on some IP addresses. Generate for me a list of 20 IP addresses that I can use to practice extended regular expressions.
Sure, here are 20 fictitious IP addresses you can use to practice creating regular expressions. Remember that these IP addresses are fabricated and may not correspond to actual locations or servers. 192, 168, 0, 110, 0, 0, 1172, 16, 0, 1203, 0, 113, 1198, 51, 100, 1203, 0, 113, 254,192, 0, 2, 254,192, 168, 1, 25,410, 10, 10, 10,123, 123, 123, 123,111, 111, 111, 111,255, 255, 255, 2,551, 1, 1, 12, 2, 2, 23, 3, 3, 34, 4, 4, 45, 5, 5, 56, 6, 6.
Okay, so obviously we can see there's something very wrong with my regular expression. It did not match any of these IP addresses. So let's think about it again. So we have 1 atom here. So there should be 1, 2, 3. Oh, do I have too many? I think I have either too many or too few. I think I have too few brackets is what's going on. All right, let's see if that fixes it. Okay, so same deal. We don't have a regular expression here that's working. I think it might be too many. Let's try it like this. Okay, same deal. Not working. So okay, so here's our special macro character. Now here's one part of the regular expression. Now we want that part to be followed by that. So we wrap that whole thing there. So now this is one atom, and then we want that atom to appear. That whole atom to appear 3 times, and then after that we have another atom, which is the digits. So I guess I don't understand what's wrong with this answer, especially if we have it really cleanly wrapped up in another set of. Yeah, I guess I don't understand what's wrong with this answer. So let's try it again. Yeah, so that's not the correct answer. Let's try changing it to single quotes, because then they'll be literal characters. Okay, so not the correct answer. Let's go to the AI and figure out what is wrong with my regular expression. So the question will be, why didn't my regular expression result in any matches?
Your regex pattern is not correctly formed. You have extra square brackets which are creating groups that don't correctly match the IP address pattern. Additionally, the needs to be repeated 3 times to match dots separating the 4 octets of the IP address, but not 4 times as you have in your regex. A corrected version of your regex pattern to match IP address is to look like this. Explanation: 0 to 9, 1, 3. This part matches a sequence of 1 to 3 digits, which covers all numbers from 0 to 999. Backslash. Colon. This part matches a literal dot. It needs to be escaped with a backslash because the dot is a special character in regex that matches any character.
Okay, so here's the one they say does work. So I guess I'm still kind of confused. What if I think basically I'm trying to use square brackets where I should be using round paren. So here, yeah, and I think a lot of these should be in round paren instead of square brackets. So like this is good to have in. Yeah, so I think this needs to be in round paren. Yep. And then this I don't even think is necessary at all. Okay, so now we have this in round paren matched, and this whole thing matched 3 times. Okay, and in round paren. So there we go. There we go. There we go. Okay, and then this in round paren. All right. Okay. So I was right about some things. I was right that this belongs like that. Okay. All right. So now let's try it. Okay, so now we have some matches, but you can see the matches are very low quality. For instance, for this IP address here, all we matched on were the zeros. We did not match the 2 digits there, which is interesting. But we are matching actual uh, IP address formats. We're just only matching IP addresses that have 1 digit for each octet, which is a problem. So something here went wrong. It looks like it's not getting the upper bound when it matches on this. I'm going to try dropping these paren here and see if that makes a difference. So it's obvious that there's something very clear about my understanding that is wrong. So hopefully we'll find it. Oh, and we need a fresh list that doesn't have the distortion due to the matches. Okay, so we've got the same result here where it's only matching the digit 1 time. Let's ask the AI about this. And we could put this whole thing in there, I think. So as you can see, there's something fundamentally misunderstood in my egrep answers where my regex only matches IPs with 1 digit for each octet. What could be what could it be that I misunderstand? Why doesn't the bound expression of that I have work to match IPs with 1, 2, 3 digits for each octet, as it is clear that I am intending. Okay, so there we go. Octet is spelled wrong. And let's go.
Your regular expression is almost correct, but there is a small mistake which is causing it to match in a way you didn't intend. The part digit 1, 3 is being interpreted as a character class that matches a single character that is either a digit or a curly brace or a comma. The correct way to denote a repetition is to place the 1, 3 outside of the square brackets. Here's the corrected version of the regular expression. Explanation. Opening square bracket,
That's
opening
dumb.
square bracket, colon. Digit 1, 3. This part matches a sequence of 1 to 3 digits.
That makes sense.
The 1, 3 outside the square brackets correctly denotes repetition of the preceding element, which is any digit in this case.
That makes a lot of
Backslash.
sense.
Colon. This part matches a literal dot. It is escaped with a backslash because the dot is a special character in regex that matches any character. Opening parenthesis, opening square bracket, colon. Digit.
Okay,
1.
so where I went wrong is these outside brackets here. So these inside brackets here with the colons denote that I'm using a special macro to match digits, but the other square brackets that encapsulate that special macro indicate the beginning and the end of an atom. So to match atoms in a bounded way, you put the open, close, curly braces after the atom. So what we did is we had a kind of nonsensical expression with this not being after an atom, but instead being after a macro. So basically, we might have been matching on this literally. I'm not sure, but I was doing it in a way that was completely incorrect. So let's see if this is now the answer. All right, and we can take what's coming in from keystrokes on the keyboard again, standard input. And there we go. It looks like for every IP address, we do have a match. So, okay, I learned something today. So what I learned is that the bounded expressions apply to an atom, and macro expressions are not atoms. They are just macro expressions, like as if they were a single digit or something like that, alphanumeric character. So you need to specify where the atom begins and where the atom ends. And if you want to bind an atom using the open curly braces, and you want to use a macro to define the atom, then you need to specify where that macro begins and ends in terms of what constitutes an atom. So there we go. Then I think these paren are still necessary. Let's try dropping those paren and see if it still works the way intended. Now I think if we drop those paren, what we'll see is this repeating 3 times, so we won't get any matches. Yep, and there we go. We don't get any matches because now we're looking for this to be repeated 3 times. So those paren are very necessary. All right, I feel satisfied with that. So let's move on. So let's take a look at the answer here. So my answer is right here. We have this first chunk here, including the final dot, and we've got we've got that whole chunk specified as being one atom, I guess. But I'm surprised. Like, shouldn't it be like this if we're specifying it as one atom? I don't get why it's not that. Let me ask the AI about that. Now, so if we're specifying this part, so if we're specifying this part as one atom and then applying a bind to it via that, then why does that part need to be enclosed in that ROM brace and not this? Why? What is, so why doesn't this expression work? This expression work the way that this expression does?
Good. Question. In regular expressions, is used to define a character class which matches exactly one out of several possible characters. So when you
Okay.
write digit It represents a single digit, and when you write ABC, it matches a single.
Okay, so I just completely misunderstood those. So this doesn't mean that it's an atom. It means it's a class of characters that you want to match. So we want to match this class of characters here, 0 or 1 times. But this does not constitute our atom. Our atom is that, and then this symbol there. So we can specify that this whole expression is an atom, not just this is one atom and this is another, by using the open closed round paren, and then we can apply a bound to this singular atom, which we know is singular because we enclosed it in those paren. So, okay, I just misunderstood what each symbol actually meant. The open closed round paren means anything enclosed is a single atom, and the open closed square bracket means that anything enclosed is used to define a class of characters where a match occurs if exactly one out of the characters specified in that character class with the open closed brackets is found in the search string. All right, so that looks good to me. So we could even make this more clear. Like, let's say that it didn't consider 0 to be a digit. So we could do 0 through 9 like that, as part of its class of characters here, and then match on that like that. Sorry, I'm actually getting like kind of nauseous out of nowhere. Let me pause it. I'll be right back. All right, back, feeling better. Did not throw up. I have no idea what happened there, but sometimes speaking is just hard. I mentioned that in the last one. It's, I think, a good modern day skill to just learn how to speak. So this channel, I think, is doing that for me. Even though it's just kind of bohemian, I should get like a coach or something. But yeah, so let's keep going on this. I want to close this out. So here we go. So yep, I got my answer for that. Kind of a complicated, sophisticated answer, but it's good because I fundamentally misunderstood the difference between a square brace and a round brace. I believe that the square brace was used to signify the start and stop of atoms, but that is what the round brace does. The square brace signifies the start and stop of a class of characters that you want to match once. All right, so the next one is how can the grep command be used to list the contents of a file /etc/services, discarding all comments, lines starting with that. So let's go to the AI and just get that file. So without giving away the answer at all, print out for me a mock services file that I can use to test my own answers to this question. Isn't this, what a world we live in?
Exclamation mark.
I'm blown
Log,
away.
etc. Services file content that you can use to test your grep command. Save the following content to a file E.g.
Look at
log
this.
underscore
Isn't
services.
this amazing?
TXT and try to write a grep command that will list the contents discarding all comments, lines starting with
Oh, you know what? I think I probably already have that file. Yeah, I already have that file, so that's okay. We don't need, unless there's not a lot of things. No, there's things that are so okay. So here's my answer. So if we do cat, what we can do is we can do pipe grep to feed it into grep as input. And then we can discard all comments, lines that start with that by saying we want a line that begins with any character 0 or more times, except for a so let's use, now that I understand what these mean, this is a set of characters that we want to match against. So we want to match against any character except for so not the pound sign. So if it doesn't begin with the pound sign, and then any character. So this is my final answer here. Oh, and you can see, it looks like we accidentally did the opposite of that. I think what I meant to do is this. There we go. Yeah, that's what I meant to do. So when the caret symbol occurs at the beginning of a regular expression, remember this is a regular expression. All this here is not a regular expression. This is a string of characters that we will apply the regular expression to. When the regular expression begins with a caret, that means the beginning of the line. But if the caret is within open, close, square braces, which is a set of characters to match against, then it means not that character. So we're saying that it has to begin with a set of these characters, and the set contains any character that is not the pound sign, and then after that it can have any character 0 or more times. So here's my answer. I'm sticking to it. Let's see what the answer is in the training materials. Okay, so this is interesting. It says a grep -v. Let's see what -v stands for. Okay, so -v stands for invert match. So okay, so that's a clever way to do it. You can do instead of this expression here, you can do -v, and then so what we can do is we can look for any character that begins with this pound sign here, and now we get all the comments back. And then we can say, actually, we want the invert of that. We want everything that doesn't apply to this rule. There we go. And then we get the same answer as we would have with this more complicated, less Pythonic regex that I used here. But both answers are correct. All right, so the next one is the file domains.txt contains a list of domain names, one per line. How would the egrep command be used to list only .org or .com commands? Oh, so this is a fun one as well. And let's get a dummy file for this one as well. Okay, so we've okay. Oh man, I'm really craving okay, well, let's move on here. So without giving away the answer at all, print out for me a mock domains.txt file. There we go. Perfect. Okay. So we're going to say echo no. So what's the command to collect no T? Yeah, okay. So we're going to use T pipe touch domains.txt. We can type in Oh shoot, that's not correct. Um. I just want to. How do I make it so that I can? Uh. Okay. So tell me what I was trying to do here, where I went wrong, and how I could have done it correctly. What a world we live in, seriously.
Recent interaction with the terminal, it appears that you were attempting to create a file named domains. TXT and populated with a list of domain names using the D command. Here's where things went wrong and how you can correct them. Where things went wrong. After invoking T and entering ASDFA, you prematurely sent an interrupt signal, Control+C, terminating the command before it could complete. In the following line, you pipe the output of T into touch domains. TXT, but touch does not read from STDIN, it just creates an empty file.
Yeah.
After executing the T, touch domains. TXT command, you started typing domain names, but since the T command was already terminated, the shell treated each domain name as a command to be executed, resulting in command not found errors for each line. How to correct it. To correctly create the domains. TXT file with a list of domain names, you can use a text editor such as Nano, V, or Vim.
Yeah.
Alternatively, you can use echo to send the strings directly into the file. Here's how you can do it using echo. Explanation. The echo command is used to print the specified strings. The E option enables the interpretation of \escapes, allowing you to use to represent new lines. The greater than operator is used to redirect the output of the echo command into the domains. TXT file, creating the file if it does not exist or overwriting it if it does. After running the above command, you will have domains. TXT file with all the domain names, each in a new line. You can verify this with the cat command.
Alright. So maybe if I use redirect. Oops. Does that work? Oh. Yeah, that works. Alright. Cool. Alright, so yeah, so I can do T redirect to domains .txt, paste it in, Control C. Yeah, look at that. Isn't that cool? I love that. I love that so much. All right, so let's sorry, I'm eating. That's probably kind of rude. Being rude is bad. It's better to not be rude than it is to be rude. That's for sure. All right, so last question. The file domains.txt contains a list of domain names, one per line. How would the egrep command be used to list only .org or .com domains? So let's think about it. First of all, this is the syntax of the egrep command. So now we need an extended regular expression. So what we can do is we can match on any character one or more times until we get to a dot. There we go. And now what we can do is we can have a class of characters that we're going to match, and have it to be an OR. So one thing we can do, and we don't even need this dot. Well, let's just have the dot. So it's going to be we can have com or org. Oh, so you can see that did not work the way intended. Alright, so this didn't work the way intended either. We see I got some false matches here on dot blog. Okay, so I guess one thing we could do is do a question mark at the end there so that we know that it ends with that. And then we can do like that. And like that. Will that work? No. Huh, that's interesting. Oh, it's the dollar sign. Oh, but now we've got no matches at all. I don't understand where my understanding is wrong. Probably just about everywhere. Um. Hmm. What if I do it like this? Oh, then I kind of do it a little bit better. Although it looks like I get some problems here. Oh, I see. So when you do the OR operator, it's the whole, because we see how we didn't match anything when it did more org. So it's not just that one part of the regular expression. It's not just the atom where you do the OR against. You do the OR against a whole regular expression. All right, so there we go. Yeah, and then if we grep out, if we cat out domains.txt, we see we're not matching on some of the other ones. So that's my answer. You can see I still have some problems understanding the difference between square and round paren. So let's get a lesson. Okay, so we're going to paste that in there. Then we're going to say to the AI, so tell me what I was trying to do here, where it went wrong, and what concept I remembered in order to come to the right answer. Give me a lesson and reinforce what I learned.
Absolutely, I see. You were busy working through a task involving regular expressions. What you were trying to do? You were trying to create a file called domains. txt containing various domain names, and then use the egrep command along with a regular expression to filter and display only the lines ending with com or where you went wrong. Initially, your regular expression patterns were not correctly formulated to match only common or domains. Here's a breakdown of mistakes. In the pattern, plus com org, the com org part was incorrect because square brackets are used to match any one of the characters inside them, not to match different strings. This led to matching strings ending with any one of the characters.
Right.
C, O, M, R, G. In your next attempts, you tried to correct it using various regex patterns, but the correct approach was to use parentheses to group com and org separately and then use a pipe to signify OR between these groups.
Right.
What concept you remembered? You realized the correct way to represent an OR condition in regular expressions is using a pipe to separate the different options and potentially grouping them using parentheses to establish the boundary of each alternative. This realization helped you to come up with the correct pattern. Plus, com. Absolutely, I see you were busy working through a task involving regular expressions. What you were...
Yeah. So I think that's self-explanatory. So it looks like I actually could have I can change this. I don't need these here. Now where they would make sense is perhaps here and here, so that you make it more clear that there's an OR operator there, and we can see that will work. But they're just unnecessary extra characters, since the uh, OR character splits it into two, so you don't need to explicitly show that that is happening, even though it might make it more readable. All right, so let's look at the answers to this one. I'm pretty happy with the answer I came up with. Yeah, so we can see it can be quite a bit easier. We're going to egrep for... oh, will this work? Let's try it. Interesting. So this works, but you can see we don't get matches here. So I don't know. So this uses it to list only. So it's the same. It's, you know, you don't need it to match here. It'll still just list that one line where there's a match. It'll list the whole line, not just the part that was matched. So this is a equally valid answer as well. Not quite as complete as mine because it doesn't match every character, but it does display each line where that partial match within the search string occurred. So you don't have to match the whole line in order to display the whole line, depending on what you're doing. All right, so that's it for the guided exercises. Next is the explorational exercises. I need a quick break again. I'll be right back. We're at the hour mark, but I'll try to close it out shortly. All right, I'm back. I'm ready to keep going. Mic check 1 2 1 2. Looks good to me. Let's go ahead and finish this up. So now we've got the explorational exercises. We've finished up the guided exercises. So the first explorational exercise: from the current directory, how would the find command use an extended regular expression to search for all files not containing a standard file suffix? So the files not ending in .txt or .c, for example. That's a tricky one. So now we can remember that when we just feed in characters like this, that's a glob character. It's not a regular expression character. So let's get a help on the find to start. Okay, so now we can see that find does accept expressions. Okay, I'm kind of surprised here because I thought there was like a -B option to change like what you feed to it. I'm not seeing that. So, oh, here we go. So we can do -regex, and then we're no longer doing globbing. We're doing regular expression. Now it doesn't say whether it's extended or whether it's standard. So it says that it's Emacs regular. I don't know if that's extended or if that's regular. So it can be changed with -regex type. So let's see if we can find some help on that. Maybe it's under actions. And we can search because we're in the less. So if we do /, you can say dash regex type. There we go. And then we've got a match up there. We can search from the bottom. So there we go. Search from the top. Okay, so we can see if we do dash regex type. Huh, that's interesting. I'm not finding it. All right, so I'm not seeing anything. So we have iRegX there, so that's case insensitive. But I don't see anything about whether it's standard or extended. I do say that regex type. Oh, here we go. So changes the regular expression syntax. So, oh, okay. So we just put a help under there, and okay. So this is what we do. We do clear find regex type help, and it's just one dash. There we go. Now here's all the types. So we've got POSIX basics, POSIX eBrush. Let's go with the POSIX extended. Okay, and then I believe all we need to do then the next step is to okay, so we're going to search for all not containing a standard file suffix. So I think standard file suffixes are, I'm not sure what they mean by that, because there's a lot of different suffixes. There's .py, there's .bak like for a backup, there's .conf, that's a really common one you'll see. There's like .pdf, .jpeg, you know, all different kinds of standard file suffixes. So I'm not sure if they mean just a dot with something after it, if that's what they mean, or like I'm not sure what an example would be of a file suffix that is not standard. So let's go to the AI and let's say please do not answer this question in any way. I am trying to study regex, but this question confuses me. Please transform it into a better question that I can learn more things from. Specifically, I find it confusing to know what would be an example of a non-standard file suffix. I don't know if the question means to simply match the syntax dot followed by any characters or something else.
Absolutely. It sounds like you'd like to explore this concept in a more structured and clear way. Let's rephrase the question to remove the ambiguity regarding standard and non-standard file suffixes. Revised question. Using the find command and extended regular expressions, how can you search for files in the current directory that do not have specific file extensions such as txt or c? Supplementary information. Understanding file extensions.
Okay, so let's answer this question. So how can we search for files in the current directory that do not have that? So what we can do is we can, so we need the quotes, of course. And then let's get another help on find. So here's the syntax for the command. So find, feed it all these options. Then there's the path, and then there's the expression. So let's do find. We'll feed it the path, and then we'll feed it the expression. And the path will be the present working directory, which is specified with that dot. So the regular expression will be we're going to have let's have a so we're going to have a series of so we want to match on .txt or .c, but we want to do an inverse match of that. So let's see if there's an option to do an inverse. All right, I don't see an option to do the inverse. So let's think about how this regular expression here could be changed so that it is it matches the inverse. So I guess one thing we could do is we could group this into one atom, and then we could do a caret like this. And then we're going to say if it doesn't match that atom, we'll include it. And then we'll do it like that. So I think this should be valid. So let's try it. Okay, so we've got an unknown. Because we didn't plug this in the way I intended to. So the regex type I want is this postix dash extended. There we go. So now we need some paths. So we need paths to precede this. So the path will be this. I'm not sure where the path goes. So it looks like we have to put a path before the regular expression. But when I try to do that, then it says that the character I'm putting down. So let's do so when I try to do that, then it says that the path I try to put is the regular expression. Oh, so I think it just needs to be in quotes. That's the only problem. But it's the same thing. No matter what I do, it interprets this as a regular expression, but it's unable to like, no matter what I put in here with the intention of putting in a path, it interprets it as a regular expression. So maybe I need to put specifically somehow denote that is a path with like a dash p or something. No, that's interesting. Huh, this is kind of fascinating. Okay, there we go. So that works a little bit better. Let's do a history. Okay, so I think just the order was wrong. I think we got to do find, and then put in the path, and then put in the regex type, and then put in the regex. Let's see if that works. Okay, so that doesn't work. So let's try putting in the let's try changing the order. Okay, so that's it. I think that's going to be my final answer. I'm sticking to it. So let's move on to the answer. So the answer is we would do the find, then we do the type f regex egrep not egrets. So you can see they did it quite a bit different than mine. I'm not sure if mine was right or wrong. So let's ask the AI. So here's my answer. Here is the answer from the learning materials. Explain the differences and similarities between my answer and the official answer from the learning materials. Tell me where my understanding went wrong, and tell me what I got right.
Let S break down your command and the command from the learning materials to identify the differences and similarities and where your understanding diverge. Your command. Breaking down your command. Find, home, gposh, you are specifying the directory to start searching from. This is correct. Caret. txt, caret. Let's break down your command and the command from the learning materials to identify the differences and similarities and where your understanding diverge. Your command. Breaking down your command. Find, home, gposh, you are specifying the directory to start searching from. This is correct. Caret. txt, caret. C. You are trying to define a regex pattern to match files. Here, the caret denotes the start of line, which means you are trying to match files that start with txt here. C, which doesn't align with the goal to find files not ending with these suffixes. Also, you didn't use this regex pattern with any find option like name or regex, it's just hanging there. Regex type POSIX extended. You are specifying the type of regex to use, which is fine. Learning materials command. Breaking down the learning material command.
Oh,
Find,
I see.
colon. This specifies to start the search from.
So it looks like the first place I went wrong and why I was getting that message is I need to specify that I'm passing it a regex like this. And then I can specify the regex type. Now is it just asking for my? Yeah, it's getting it from standard output if I do it that way. That's interesting. Okay, so this is better. It's actually doing it. So I think we can put the dash regex type. I think we can put that here. There we go. So I think this is better, but then we do need to fix up this portion of it. Here, so for this, I was attempting to use the caret to specify not matching the characters. How could I change this expression to do what I was intending.
Regular expressions, the caret is used to denote the start of a line or string, not negation.
Not
To
necessarily.
specify negation in a regular expression, you typically use a caret inside square brackets like this, caret.
Oh, okay.
Where represents the characters you want to negate. In the context of your task, where you want to match file names not ending in certain suffixes, you don't specify negation inside the regex itself.
I mean, you
Instead,
could.
you specify negation in the find command using the not option. However, let's correct a regular expression to match files that end with txt here. C. Colon. Matches any character. 0 or more times. Backslash. Matches a literal dot. We use a backslash to escape the dot because it is a special character in regex. Txt, C. Matches either txt or C. Dollar. Asserts position at the end of the line. To use this in your find command to find files that do not end in txt here. C, you would use the not option as well, like this. Not. Negates the regex, finding files that do not.
Okay, but how would you do it? Okay, but how would you do it if you couldn't use dash not?
Find files that do not match a certain pattern without using the not option. You would need to use a more complex regex that matches all strings except those that end in the specific patterns. However, creating such a regex would be quite complex and potentially very long, especially for more
Would
complex
it?
patterns.
No, it wouldn't.
A simpler and more practical solution in a shell environment might be to use other tools like grep to filter the results from find.
What about just simply doing this?
Regex. Backslash. Caret txt, caret C, dollar you propose won't work as you might expect to match files not ending with txt here. C. Let's break down why. This part matches any character. 0 or more times, which correctly matches any sequence of characters before the file extension.
Okay, so that's good.
Backslash. This correctly matches a dot, which is often found before file extensions.
Yeah.
Caret txt, caret C, this is the problematic part. And denote a grouping, and caret txt matches a single character that is not D, not X, and not D,
Yeah.
rather than not matching the sequence of characters.
Okay, so I don't really understand that too well. So what I've got here, in now the regular expression itself is fine for matching it. So you can just use the dash not and match anything that doesn't match it and be totally fine. But if you don't have the dash not, wrapping txt in square brackets and then appending it with the caret doesn't work, because what you're doing with the square brackets is you're creating a class of characters to match against one time. So for each character in the class, you apply a match if any one of those characters match. So the characters I have within these brackets are anything that's not a T, a X, and then a T. So that's not going to work because we're not matching on the characters in the search string T, X, and then T. We're only matching on a single character, not three of them. So if we want to match on 3 characters, we could make this work by having this syntax 3 different times. So this is a valid answer here, where we just separate them out into 3 different atoms, and then the atom is a class of characters, and the class of characters is anything that's not a T for the first atom, anything that's not an X for the second atom, and then anything that's not a T again for the third. So that is perfectly valid. Oh, I thought it was. What about, let me ask it this. What about this?
Backslash. Caret T, caret X, caret T, caret C, dollar would not accurately capture file names that
Oh,
end with
okay. Why not?
txt here. C for a couple of reasons.
Oh,
Let's
I think I made a mistake. Um, First of all, I don't need the parentheses. Oh wait, I do, because I'm saying, so this is all one atom. Uh oh, I think this is fine, isn't it? Huh. All right. Anyways, what it's telling me is that just use the dash not option. It's there. You'll never find that doesn't include it. So that's the easiest way. All right. So the next explorational exercise is the command less is the default paginator for displaying long text files in the shell environment. By typing / a regular expression can be entered in the search prompt to jump to the first corresponding match. In order to stay in the current document position and only highlighting the corresponding matches, what key combination should be entered at the search prompt? Okay, so by typing the / a regular expression can be entered, and then we want to stay in the current document position. So we only want to make matches within the document itself. So I'm not sure about this one. Let's start with a help. So let's do a man on a find command. That takes us to less. We'll do an H. Okay, so now we've got a summary of less commands. So let's take a look at the /. Okay, so /. Now we've got search forward for this. This is tricky. Okay, so searching. Okay, so here's one that's probably pretty good. So here's probably it. A caret K / caret K would probably be a good one. Yeah, I think I'm gonna go with that. Okay, so / caret K. So we're not gonna jump around. And then okay, and then in order to stay in the current document, what key combination should be entered at the control prompt? My answer is caret K. Let's see if I'm correct. So pressing Control K before the search expression. So I was right about the character combination, but I wasn't right about how you enter it in. You can see here what I said to do was hit the /, then type caret and capital K into the / prompt. But the answer is instead of doing that, what you do is you type the /, then you hold down the control key, the shift key for uppercase, and then K. And now we can see the prompt changes to say keep - position. And if we search for search, now we're only matching within our currently displayed characters on the terminal screen that we have now. So that's really good to know. It's probably a better way to do it most of the time. All right, so the next way, in less, how would it be possible to filter the output So only lines which match a regular expression get displayed. So let's go to the help menu for that. It looks like we're already there. We want to get help on maybe searching or moving. Probably searching. So if there's anything about filter, let's look for filter maybe. So we're going to do Control Shift K, and we're going to type in Control Shift K. Oh, sorry, we're going to do / Control Shift K, and then we're going to type filter. And I don't see anything written about filter. All right, well, I don't see anything there. I mean, what you could do is how would it be possible to filter the output? Um, um, so that wait. Okay, so I don't see anything about filtering the output. I know that we can highlight the output, but I've never really heard about filtering the output just within less. I know that you can do it just from the bash CLI. Let's type in filter. Okay, pattern not found. So I know you can do it if we do like a pipe grep pipe less. So like for example, if we do cat file list.txt pipe grep, and we'll say like .txt pipe less. Now we get all the filtered output like that. So you know what? That's going to be my answer, and I'm sticking to it. Probably wrong, but we'll see. Okay, so yep, that was wrong. So the real answer is you push the ampersand. And then you enter the search string. So let's try that. Okay, so we're going to do a man on find, and then we're going to hit the ampersand. And there we go. We've got a prompt at the bottom that says ampersand / We're familiar with what the / does. It's the search. So let's search for the word options. And there we go. Now we've only got lines that have the word options in them. Perfect. All right, so that's it for the exercises. Making good time. We're at 1:33. 2 hours is too long, so let's finish it up. This is the summary. This lesson covers the general Linux support for regular expressions, a widely used standard whose pattern matching capabilities are supported by most text-related programs. This lesson goes through the following steps: what a regular expression is, the main components of a regular expression, the differences between regular and extended regular expressions, how to perform simple text and file searches using regular expressions. All right, so that's it. This is a big lesson, and this is only the first part. So stay tuned for lesson 2. Thanks for watching.